Good day everyone, we're going to take a look at exercise 28, which is the first exercise after theory B of chapter 8.3. So we're now going to calculate using scale factors. And just to be wary, I have tried to resize this to the correct size in your book, but it can be that it's a bit of a different size, so maybe I can find different values than you do, okay, because I have to copy paste this from the online book. So when I'm going to measure, it can be slightly different. They show us the image of this dinosaur and they show us an enlargement right here. So this is the object, this is what I start with, the original, and this is my enlargement, the image. If I want to calculate the scale factor, k, I have to do a distance in the image, so distance image, divided by a corresponding, that's abbreviated, corresponding distance. That's not how you write distance. Distance in the object. So I have to measure using my protractor two measurements that are the same. So for example, if I take out my protractor, it must be something that's visible in enlargement B at least, right? In the second enlargement. So what I could do is, for example, measure the, let's do it like this a bit, the distance between his mouth here, from this here to there. It's around 3.1. That's the image, so I can say it's 3.1 centimeters and divide that by whatever it is right here. That's 0.8. And that's my scale factor. And just to check, right, if I'm going to calculate this, my scale factor will be 3.875. On the test, I won't mind if you are a bit off, but don't be off by a lot. So if you find 3.0 divided by 0.7, okay, but not 3.5 divided by 0.6, for example, 0.5. Could also be that you measured a different dimension. Maybe you measured the distance between his teeth, for example, here and here. Then you find different numbers here, but not a different scale factor, because maybe a bit different, but not too much of a difference, because otherwise not all lines would scale the same. So your scale factor must be the same. Remember, a scale factor doesn't have a unit, so no centimeter, no kilograms, whatever you want to name up, just like this. This means every line in my enlargements is 3.875 times as big as in my original. Every line. I need that at B. Because at B they say calculate the height of the enlargements. And I don't know that because I can't measure it. They only give me part of the enlargements. But they do give me the height in the object, what I start with. Right, so I take out my protractor again. And now I measure this height, which is around 2.2, 2.3. If I'm correct, let's see if that is the same as in my book. See, in my book I'm a bit, oh no, it's the same, 2.8, around 2.8. So the height of my object, so I did resize this pretty damn good, if I say myself. It's going to be 2.8 centimeters. So what's now the height in the image, or in the enlargement, right, that's the same. Immense. Well, every line becomes 3.875 times as big. So also the height. So the original height was 2.8. The new one is 3.875 times as big. And again, remember, you may use your calculator during this chapter 3.875, which gives me an enlargement of, no, not approximately, exactly 10.85. Again, I might be a bit off. Maybe the answer book says something different, maybe 10.7 or maybe even 11. If you're a bit off, I don't mind that much, but to be sure, always write down intermediate steps like this so I know what you have done. If you measure 2.7, well, okay, right? Especially here where the lines aren't that straight. I think a straight line is a bit easier to accurately measure. But here you can be a bit off, but you should be around this number here. And here I do know we're talking about centimeters, because we've measured in centimeters, right, on our protractor. Okay, good luck with the other exercise as well. Remember, sometimes you have to use your protractor to measure things. Good luck.